Hi everyone, this is Dr. J. Nirmala Devi, Associate Professor from the Department of Information Science and Engineering. Today we are going to see about a very interesting topic, and let us understand the topic with the help of a game. The game what we are going to see is about chess. We know that chess is one of the game played globally by the players, and this is considered as one of the most intelligent game. Here, what we are seeing are the coins used in the chess game. The coins are king, queen, bishop, knight, rook, and pawn. Each coin is used for different purposes. And knowing the purpose and the guidelines, the player has to play the game. Normally, the chess game is played between two players. Each and every player will make their own move. And whenever player 1 is making his move, he has to click this chess clock, and when the player 2 is making her move, she has to click this chess clock. This clock is used to predict the amount of time taken by the player to complete their move. Also, we can see that the chessboard is made up of 64 squares arranged in an 8x8 grid. Also, the coins what we have seen has their own way of moving in the chessboard. So few coins has to move forward, backward, and few other coins has only one step movement. So all these things are given as the guideline for playing the game. And based on this, the players has to make all the permutations and combinations before making a particular move. Each and every move is considered as the intelligent move. And when one player lose or one player could not able to move further and get stuck because of the movement made by the other player, that particular player will have the chance to win. So this is the way how the game proceed. Now we can see this game can be played between a human and a robot. So that means, is that possible whether a human can play the game with a robot? Yes, it's possible. How? We can say that a machine have some intelligence. So we say that those machines are called as intelligent systems. So these intelligent systems have some intelligence behavior. So that means that they can understand certain things and they can work on particular tasks. So this is called as some intelligent behavior of the intelligent system. So these intelligent systems are of various types and used for various applications. Now, what we can understand the basic characteristics of any intelligent system is these systems will have perception, reasoning, learning, communicating, and they can take some action in complex environments. So all these things are some of the characteristics of any intelligent system. And now what we are seeing is about an machine learning system where it can detect an image of a dog and it work on the input and it is using some algorithms inside it and it is creating the output. So it is matching whether the already given images are mapped with the given input. So the same way any number of images can be used for identifying that whether that is the right image or not. So when a system is said to be intelligent, it has to work on some intelligent algorithms. So what we say, these algorithms are called as the intelligent algorithms which can make some decisions for any complex problem. This intelligent algorithm has the ability to comprehend. So it has to decide whatever it can do with the given input. It has the ability to understand. It has the ability to interpret intelligence. And finally, it should have the capacity for thought and reason. So before making any decision, these intelligent systems are working on the algorithms to make some decisions for the given input. And these intelligent algorithms have some aspects of intelligence which includes creativity, skill, consciousness, emotion, and it has to work with some intuition. So before making any intelligent based decision, so it should work on all these to make the final decision. Now we move on the important concept called as computational thinking. All these intelligent system has some computational thinking. So this computational thinking normally has various steps. So the steps are decomposition, where it is breaking down the data and problem into smaller parts before making or before working on the complex problem. And it has the second step as pattern recognition. So here it will observe the patterns and the trends in the data. And the third step, it is about the algorithms. So it will determine the algorithm what to be done to solve the problem. So that is what about the algorithm is. And the last step is about the abstraction. So when abstraction comes, it will remove all the details and extract only the relevant information for making the decision. So this computational thinking is very important in making the decision.
Computational thinking. What is it, and why is it so important? Let's start by looking at the what. You may think that computational thinking is about thinking like a robot or programming like an expert, but it's not. Rather, it is a very versatile skill, a skill that focuses on critical and logical thinking. To put it simply, computational thinking is a problem-solving skill. Let's dive a little deeper. Computational thinking is about looking at a problem and solving it systematically, and therefore arriving at a solution that both humans and computers can understand. Essentially, it is considered the highest order of problem solving. Computational thinking is made up of 4 elements: decomposition, pattern recognition, abstraction, algorithmic thinking. First of all, decomposition. Decomposition is about breaking a difficult problem down into simple and easy to manage parts. Second, pattern recognition. Problems come in all shapes and sizes, but amongst their many differences, there are bound to be similarities. Pattern recognition is about spotting what different problems have in common and using what's worked before to help you out again. Third, abstraction. Abstraction is all about focusing on the details that matter while ignoring the ones that don't. By applying abstraction, we can cut through fluff to get to the heart of the matter. Finally, algorithmic thinking. Algorithm is really just a big word for a set of rules. So algorithmic thinking is basically when you generate a series of simple steps that anyone can follow to solve a problem. Now, let's bring everyone together with a simple example. Meet Max. He's your average hardworking young man, trying his best to be a productive member of society. But today, Max's car has broken down. Luckily enough, he's computational thinking enabled. Let's see how he solves this problem. Max's car can't move too well. He realizes that there are 2 problems. He's running low on fuel, and he has a flat tire. That's the first pillar, decomposition. Now Max has been in a similar situation before, and based on past experience, he knows that he should take care of the flat tire first. That's the second pillar, pattern recognition. He doesn't have much fuel left, but it's enough to get him to the next patrol station, so he decides to ignore that and focus on the tire. That's the third pillar, abstraction. Finally, to change a tire, Max has to use a jack to elevate his car, loosen the nuts on his tire, remove the tire, and replace it with a new one. Now that's algorithmic thinking. As you can see, computational thinking isn't just for computer scientists or programmers. In fact, many kinds of people, from mechanics, doctors, to presidents, are subconsciously applying computational thinking in their daily lives. Thanks, Max. Have a nice day at work. So why is computational thinking so important? It's not. That is, if you don't mind being left behind in the Stone Age. According to Moore's law, computing performance doubles every 18 months. That is to say, in 10 years, a $1,000 computer will...
So now we got clear about what is computational thinking. Now we can go with the actual topic, which is computational intelligence. So the computational thinking leads to computational intelligence. So where the system can think by itself for taking any complex decisions. And What we are seeing now is about a computational intelligence system where it is a robot is making a move of rolling a trolley. This computational intelligence defines that the ability of a computer to learn certain tasks, and whenever the computer decides on its own, it has to work on some data or experimental observation. So here what we are seeing is an image where on the left hand side we are having some sign language symbols, and these symbols are worked on with some intelligent algorithms, and the final addition is taken by the system and it is showing its own output as the machine learned output. So this is one of the example how the computational intelligence works. So it makes the computer to learn certain task, and based on that task it will give the outcome. This computational intelligence is the sub-branch of AI. So that means artificial intelligence sub-branch is your computational intelligence, and it is not exactly like have the definition of the computational intelligence. Instead, we can say that it is the synonym of the soft computing. And this computational intelligence is a combination of the nature-inspired computational methodologies and approaches, and it addresses the complex real-world problems. And finally, we can say that this computational intelligence takes advantage of the human, where a human can work on some mathematical and traditional modeling. So the same way the system will work on the mathematical and traditional modeling. The computational intelligence has various paradigms here. So what we are seeing are the various paradigms of the computational intelligence, which includes your artificial neural network, your evolutionary computation, swarm intelligence, artificial immune systems, fuzzy systems. And even though we are saying that there are 5 paradigms of computational intelligence, only 3 are considered as the pillars of computational intelligence. They are neural networks, fuzzy systems, and evolutionary computation. Let us understand this one by one. What is this neural network? So the neural network is nothing but a massively parallel distributed networks that has the capacity to learn and generalize from examples. So whatever example you are training on the system will work on it, and based on the examples, it will match the given data and produce the output. So that is what called as the neural network. So let us understand this with a video.
What is a neural network? Let's say artificial neural network, as we are talking about human-made mathematical model, original creators of which were inspired by human brain performance. The desire was to mimic the mother nature, creating a sophisticated, intelligent system capable of performing similarly to biological neural networks of human brain. Neural nets could be defined as a network of many simple processors, neurons, each having its own small amount of local memory. The neurons are connected by communication channels, or connections, which usually carry numeric data, variously encoded, and can operate only on their local data, plus inputs received by connections. Every connection has its weight, which reflects the strength or amplitude of the connection between 2 neurons. Biological equivalence of a connection weight would be the amount of influence the firing due to some excitation cause neuron has on another neuron. Another parameter defining the life cycle of a neuron is threshold, which reflects the level of excitation when a neuron is ready to fire a signal. It's a neural net. Every input neuron is connected with some numbers of the next or hidden layer neurons, and they are in their turn with output neurons. What neural nets can do? In principle, they can compute any computable function, but they have to be well trained. That's the challenge. The most important aspect of neural nets, learning. Similar to human, we must be able to learn, to be trained from examples. So, we are downloading human knowledge into a machine and training it to perform the task better than a human. To put it in a nutshell, where we use neural nets, they are working in robotics, medicine, weather forecasting, banking and finance, chemistry and criminology. You're facing them in face recognition systems, and you play games with them. Neural nets are perfect chess, checkers, tic-tac-toe players. But is it all we were dreamed about? Where is an intelligent, artificial colleague who can help us solve the problems we don't know how to solve yet, able to learn himself and discover innovative ways? Alas, we can't copy the magic process of human brain. Modern neural nets still are not inventors. They can do only what they've been told to do. So we're stuck? A qualitative jump is needed. We still can try to imitate our own brain behavior, but then we have to answer the question, what human consciousness is. The other way, to let neural nets evolve themselves, naturally, using genetic evolution, like Mother Nature. But we must be absolutely sure we are ready to engage with thinking machines.
Now let us see the applications of neural networks. The first application is learning lip synchronization from audio. Here, the lip movements are synchronized from the given audio. So this is one of the application of neural network. Also, we can have the other application like text classification and categorization. So when we have the Facebook reviews, we are seeing lots of comments are there in the Facebook. So that can be classified based on the product review or based on the emotions the people are sharing about the product. All these things can be categorized with text classification and categorization. And the next is language generation and multi-document summarization. If we have a particular text, that text can be generated for a particular language, and when we have multiple documents, the pages can be given in a summarized way. So that is possible with the help of the neural network. And the other applications include machine translation, where we can translate from one language to the other language, and speech recognition, where you can identify a particular speech, and we have character recognition, where a particular characters can be recognized using neural networks. All these things are possible with the help of the neural network. There are lots of research going on the neural networks, which is based on feed-forward neural networks, recurrent neural networks, self-organizing neural networks, deep learning, and convolution neural networks. When we say about convolution neural networks, we can go with an example of medical imaging. When we say that it is medical imaging, lots of medical classification and segmentations are required. These are done with the help of convolution neural networks, and these convolution neural networks helps in identifying brain tumors, lung cancer, etc. Now we move on to fuzzy systems. The fuzzy system model linguistic imprecision, and it will solve uncertain problems based on a generalization of traditional logic. And this fuzzy system enables us to perform approximate reasoning.
A tool engineers and scientists use to add intelligence into robots, video games, and even in household appliances. Fuzzy logic is fantastic, as it solves complex problems by using simple rules. Let's see how an intelligent robot tackles the challenging task of boiling an egg using fuzzy logic. Boiled eggs are popular for breakfast worldwide. Boiling an egg sounds trivial. However, only a few have mastered the art of preparing the perfect soft-boiled egg. This is Jane, a robotics engineer. She will help us with the robot design. Initially, Jane had designed the robot according to her grandmother's recipe book.
Drop them in boiling water and remove them after 5 minutes.
Unfortunately, the eggs sometimes turned out too soft or too hard. Jane decided to ask her best friend Mike, who is a chef, for some tips. Mike noticed that Jane's robot didn't consider the egg size when deciding the boiling time, so he gave Jane 2 simple rules to follow. If the egg size is small, then boil for less than 5 minutes. If the egg size is large, then boil for more than 5 minutes. But Jane thought,
What does small, large, less, or more mean? We know that egg weights can range from 40 to 70 grams, with boiling times ranging from 3 to 6 minutes.
fuzzy logic utilizes this knowledge. Designing the intelligent egg-boiling robot requires 3 steps: fussification, inference, and defussification. Step 1. Fussification. The robot takes an egg and measures its weight. According to fuzzy logic, any egg is both small and large, but to different degrees. For example, our robot considers a 50-gram egg as small in a larger degree and as large in a smaller degree. Those are called fuzzy values. Step 2. Inference. Since the egg is both small and large in different degrees, the robot applies Mike's 2 rules, but again in different degrees. Step 3. Defussification. The robot must now calculate the actual boiling time based on the fuzzy values from the previous step. Hence, for the 70% less and 30% more than 5 minutes boiling time, a balanced decision would be to boil the egg for 4 minutes. Our intelligent fuzzy logic egg boiling robot is now ready.
Now we see about the ongoing research in fuzzy systems. Fuzzy sets and systems, fuzzy clustering and classification, fuzzy controllers, linguistic summarization, and fuzzy neural networks. When we say about linguistic summarization, this is used in something like the homes of elderly people where an in-home sensor data is used. The in-home sensor data will collect the sensor details about the health reports of the elderly people, and that is converted to the natural language. Also, the fuzzy controllers are used in the latest washing machines where it can identify the level of the water using weight of the cloths. So for all these things we are using the fuzzy systems. The next one is about evolutionary computation. This is a technique of computational intelligence, and it solves optimization problems by generating, evaluating, and modifying a population of possible solutions. This technique is inspired by natural evolution. Some operators are inspired from natural evolution such as crossover, mutation, selection, and reproduction are applied to individuals. Based on the fitness values of the newly evolved individuals, a new population is generated. That logic is applied in this evolutionary computational.
Evolutionary computation, a technology inspired by nature. Why do chickens look like this, and why are airplanes built like this? The reasons may not be that different. Evolutionary computation. Evolutionary computation, a technology inspired by nature. Why do chickens look like this, and why are airplanes built like this? The reasons may not be that different. Evolutionary computation mimics the concept of natural systems evolution. Like survival of the fittest, evolutionary computation retraces nature's path to find the best possible solution. What are the analogies between biological evolution and evolutionary computation? Suppose you're a chicken and you live on a yellow leaf. To survive, you need to protect yourself against predators. The best way to do that is to blend in with the background. Now let's use evolutionary computation to mimic what happens in nature. So what do we need to perform evolutionary computation? An encoding. RGB coding is the chromatic DNA for an artificial chicken. A performance evaluation method to assess color fitting. And at least 2 evolutionary computation operators: selection, mutation, and crossover. Let's start searching for the perfectly colored checker using an evolutionary computation method. generation of geckos is populated by sampling random colours. We start with 8 RGB combinations. Just like in nature, less fit individuals are eliminated. The surviving individuals go through an evolutionary process that produces a new generation of geckos by mutation. And crossover. And so on for 20 generations. The 20th generation is close to the perfect match. That's evolutionary computation replicating a natural process. With the same method, you can search for the perfect airplane wing. You can use evolutionary computation to optimize products, systems, and computer programs. That's how nature inspires technology to achieve perfection.
Thus is about the evolutionary computation. There are lots of research going on in evolutionary computation, which includes genetic algorithms, evolutionary programming, evolutionary strategies, genetic programming, swarm intelligence, differential evolution, evolvable hardware, and multi-objective optimization. When we say about genetic algorithms, these are commonly used to generate high-quality solutions to optimization and search problem by relying on biological-inspired operators like mutation, crossover, and selection. When we say about something like swarm intelligence, this is a collective behavior of decentralized, self-organized systems, natural or artificial. And the concept is employed in work on artificial intelligence. These are the various researchers in evolutionary computation. In the further classes, we will be seeing in detail of all these. Thank you.